705 Z-scores. Now, ladies, listening. Instead of writing, and took us a long time, we had to keep writing it, mean plus 1 standard deviation, mean plus 2 standard deviations, mean plus 3, mean minus 1, mean minus 2 standard deviations, mean minus 3. Guess what? We don't have to write that anymore. We just put a Z-score. Now, a Z-score, instead of writing that, we can write Z-score. Z-score is a standardized score which shows the position of a raw score relative to the mean. So we let the mean have a Z-score of 0. Mean plus 1 standard, so 0 is always the mean. Mean plus 1 standard deviation means Z-score of 1, plus 2 standard deviation, Z-score 2, plus 3 standard deviation, Z-score 3. Isn't it easier, instead of writing all that, just to go 0, 1, 2, 3, negative 1, negative 2, negative 3. Mean minus 1 standard deviation, you just write negative 1. Mean minus 2 standard deviations is negative 2. Mean minus 3 standard deviation is negative 3. But guess what? Every score, if it's a nail or some distribution of something, it doesn't exactly have to sit on 1, 2, 3. You can have Z-scores of 0.1, Z-score of a half, Z-score of 1.6, Z-score of 2.9. You can have a Z-score of 4. You can have negative Z-scores. So if I tell you it's got a negative Z-score, it's below the mean. Do you get it? If you've got a positive Z-score, you're above the mean. So, for example, a Z-score of 1.8 means that your score is 1.8 standard deviations above the mean. So that might be here, 1.8. And a Z-score of negative 0.5 means that your score is half a standard deviation below the mean. So positive Z-scores, your value is bigger than the mean. Negative Z-scores, your value is less than the mean. Now, why do we need the formula? Because every piece of data does not sit exactly on 1, 2, or 3 standard deviations, or at negative 1, negative 2, negative 3 standard deviations. So we have a formula for working out maybe the Z-score of minus 0.7. All right, stuff like that. So the distribution of Z-scores is a normal distribution with a mean of 0 and a standard deviation now is 1. All right, in terms of Z-scores. So here's the formula that you will see on your formula sheet. Z-score equals the score you want that they're talking about minus the mean over the standard deviation. So let's just practice what that is. Now, the ages of bingo players are normally distributed. We're going to use the formula for question 1, but I'm going to draw it as well so you see how it makes sense, all right? So question 3, the ages of bingo players are normally distributed. The mean age is 70. So just down at the bottom, I'm going to do the graph. The mean age is 70, so I'm going to call that Z-score 0 now instead of going mean. And the standard deviation is 6. So what are my numbers? 70, what's my next number? I can't even draw a straight line. 76, I call Z-score 1 now instead of going mean plus 1. Got it? What's the next one? 82 is a Z-score of 2. Anyone got the tape, please? Mean is 70, the standard deviation is 6, so instead of going mean plus 1 standard deviation, I go 0, 1, 2, 3, they're my Z-scores. And these numbers, 52, 58, 64, are my actual scores. Do you get it? So, you tell me, it says, if the ages are standardized, what is the Z-score for someone getting 76? You can see it on my graph. 1, but let's use the formula. Z-score is X minus X bar over S. Let's look at our question. What's the X bar? That's the mean. What's the mean in our question? And what's the standard deviation? So S is standard deviation is 6. Let's substitute into our formula. Bill is 76 minus the mean is 70 over the standard deviation is 6. What do you get? So I can also use the Z-score formula or the number line. Now, number line only works for Z-score 1, 2, 3, 0, negative 1, negative 2, negative 3. If the score is 77 or 80, you can't use the number line. All right? So what do you get? 6 over 6 is 1. That worked. See? 76 is 1. Let's look at Mary at 52. You can tell me the answer already. What's Mary's Z-score? Look.
Negative 3.
Yeah. So let's use the formula. Z is X minus X bar over S. Mary's score is 52. Take away 70. That's her Z score over S. So her Z score is what? Isn't that negative 18 on 3? It's negative 3. That works. We can see it on the number line. So if you have a question and you're drawing the number line, they want the z-score, if it lies on one of those points, you don't need to use the formula. Do you get it? And the last one, Elsie. You tell me what her z-score should be greater than just by looking at the number line. It's bigger than 3. She's above 88. See, z-score, a score of 88, an actual score of 88 is a z-score of 3. She's higher than that. You are allowed to go higher than 3. It's just that, why do we do negative 3 and 3? So, because that's where 99.7% of the data lies. So, she is x minus x bar over s, 91 minus 70 over s, that's 21 over 6. Standard deviation, 6. So, what do we get? 21 over 6, 3.5. That makes sense. That it's bigger than 3. Just a bit bigger than 3, 3.5. So that's how we use the z-score formula. Now, like I said, with these numbers, what percentage are between negative 1 and 1? 68%. Same percentages. Between negative 2 and 2, 95%. Between negative 3 and 3, 95% for the second one, 99.7%. What's new about this exercise? The numbers, 0, 1, 2, 3, 0, negative 1, 2, 3, and the formula. Everything else is the same. We're going to do all the same questions again. Let's go. Emma's age has a z-score of 2.5. I could actually work it out. You know 2.5 is halfway between 82 and 88. I could work it out by just guessing on that graph. What do you think? Yeah, it is 85, but let's use the formula. Z equals x minus x bar over s. So if her z-score is 2.5, what is her score? We don't know. What is the mean of this data? They gave it to us at the beginning of the question. What's the mean of the data? Anyone? 70 over. What's the standard deviation? 6. Now we have to solve. How do we solve this? How do you solve it? Don't you multiply? What's the inverse of x minus 60 divided by 6? Inverse operation of dividing by 6 is times by 6. 2.5 times 6 is 15. Is x minus 70. How do I get x on its own? Inverse operation of take away 70 is to add 70. And as you all told me before, x is 15 plus 70, which is 85, just as we thought. Because see, 2.5 is exactly halfway between 2 and 3. So it's exactly halfway between 82 and 88. So I could have done it, just the average if I want, of 82 and 88. If I wanted, using the number line. I could have done this using the number line, which we did in our head before we started. Do you get it? But you can use the formula. Now the next question is, what percentage of bingo players are more than 82 years old? This is what we did in the last exercise. More than 82, I need there onwards. Now, if you want there onwards, you've always got to do your 50%. So, what have I got? What is from 70 onwards? What's that? Good. I need the yellow bit. I've got to take away this bit. Do you get that? 50% is the black bit from there all the way to the end. I only need the yellow bit. What's this bit from 0 to 2? The bit from 0 to 2 is half of the bit from negative 2 to 2. Half of 95. Do you get that? From negative 2 to 2 is 95%. From 0 to 2 is half of that. So it's half of 95. So I'm just going to go 95 divided by 2 is 47.5%. So that's what that bit is, 47.5%. What's your bit? You need the yellow bit. What is it? Yes, the yellow bit is 50 minus 47.5%, which is 2.5%. Okay? And the last question is asking you what percentage of players are between 64 and 88. So I'm going to draw this again. 64 is down here at negative 1. and 88. Now that was 0, 1, 2, 3. Now, when you're doing from a point to the end, you've always got to use the 50%, always, right? But this one, when it's from one bit, like -1, through to 88, you don't use the 50%. I want all of that. Now, all of that passes through 0. I stop at 0, and I work out the two separate bits. I need to work out from -1 to 0, and from 0 to 3. If I want the percentage of players between 64 and 88, I've drawn it again. So you need to do half of... So, girls, there's my z-score of 0. That's my mean. I know from -1 to 1 is 68%, right? But I just want from -1 to 0. Do you see what I'm doing? My figures are from -1 to 1 is 68, but I want from -1 to 0. What's that? 34%. All right? Now, I also know the other figure I've got. I need to know, sorry, from 0 to 3 now. Do you get it? From 0 to 3. I know from -3 to 3 is 99.7%. So, therefore, from 0 to 3 will be half of that. Do you get that?
Yeah.
Isn't that 49.85%?
Yeah.
So now you have to add 34% and 49.85% because you want the whole blue bit. So we need to add the underlined ones. So what percentage of players? It's going to be 34 plus 49.85, which is 83.85%. We've done this number before. Remember that number? Yeah. Now, size just the numbers and the z-score formula. Jelly beans are put into 100-gram packs, and the machine that performs this task is set to a mean or average mass of 100 grams with a standard deviation of 2. Do you know what you're going to do? So there's your mean. What number should I put above the 1? And these are the z-scores. 102, beautiful. 104 is, and then 106. And this is 0, 1, 2, 3. Do you know what we're doing? It's like my number line, but in a table. All right? Now what happens here? 98, what? 96, 94, downwards. What about here? Negative? Negative what? -1, -2, -3. Lovely. So that's the table of z-scores as opposed to doing it on a number line. All right? What percentage of packets will have a mass of more than 100? Oh, this is nice and easy. Yeah, it's half of them. What percentage of packets will have a mass of more than 100? Well, 100's at the mean. It's the average. More than 100, that's half your graph. So that's 50%. Between 98 and 102. What's that? Between, so that's from -1 to 1. What percent's that? -1 to 1. Anyone? That's 68%. Good. Less than 96. All right, this one's going to be a bit tricky. Less than 96. So, well, you want from there down. Now, do you know what it is? So, if we knew what 0 to -2 was, that would be good. What's -2 to 2? What percent from -2 to 2? So, do you think I need to know this bit? No. -2 to 2 is 95%. What's 0 to -2? No. 95 divided by 2. Look, do you understand you need this highlighted bit down here? Right? I know that from the middle of my graph down is 50%. The middle of my graph down is 50%. All right? Part 3 is asking me less than 96. So I need to know from a z-score of -2 down. Now, that will be 50% minus the blue bit. will be the yellow bit. I need to work out the blue bit. Now the blue bit's from -2 to 0. I don't have numbers for -2 to 0. I have numbers for -2 to 2 is 95%. So half of that is 47.5. So this bit in blue is 47.5%. So what's my yellow bit? What percentage are less than 96? What do I do? From there down is 50%. This section here is 47.5. What's that? It's 50 minus 47.5. Do you not get that? Question C. It says the mass of 2,500 packets, the masses of 2,500 packets are noted. How many are expected to be greater than 104 grams? Now, girls, this is symmetrical graph. Well, how many are bigger than 104? That is from here upwards. That's bigger than 2 standard deviations. Yeah, it's the same value as from, look, you know -2 down was 2.5%, 2 up is also 2.5%. No, yes. It's the same. So 2.5%. So from 104 grams and up, that's 2.5%. How did we get it? It's 50% minus 47.5%, like we did before. All right, it's symmetrical. So what do I do? 2.5% off what? See, 2,500 is all the packets. 2.5% of them should be bigger, way more than 104 grams. So what do I do? 2.5% of 2,500.
34%.
So it's 62.5 packets. You could put either 62 or 63. Just leave it at 62.5. So it's either 62 or 63 packets, basically. 62.5. You can't choose either one. At the specimen paper, question 27E. The marks in a test are normally distributed, and you think, great, I can use my percentages, 95, 68, 95, 99.7. The mean is 70. I really think you should be drawing every single question. The mean is 70. That's a Z-score of 0 now, isn't it? And the standard deviation is 10. What's the next thing I put? 80, 90, 100, 1, 2, 3, yeah? -1, -2, -3, and keep going down 10. All right. So that gives me my picture of the whole thing. There's my mean. There, I'm adding my standard deviations on. You know, most people got between 40 and 100, we could see. 99.7% of people got between 40 and 100. Where's Jason? He's sitting in here. See where Jason is? Jason's mark is 85. You should be able to tell me right now what his Z-score is. It is 1.5, but let's use the formula. Z-score is X minus X bar over the standard deviation. So, Jason's mark is 85. The mean is 70. And the standard deviation is 10. So that's 15 over 10, which is 1.5. We already could see it from the graph that his Z-score is there. There's Jason. Jason. His Z-score is exactly halfway between 1 and 2. Because his mark is exactly halfway between 80 and 90, right? Mary's has a Z-score of 0. What mark did she get? What's a Z-score of 0? Z-score of 0 is the same as the mean, which is X bar, which is 70. There's Mary. That's right. And last question. What percentage of marks lie between 50 and 80? Now look where we're going from 50 to 80. Just move Mary and Jason out of the way. Here's Mary, here's Jason. Okay. Now, what percentage of marks are between 50 and 80? Here's 50, there's 80. When it passes through 0, you should break it up. I put a line at 0. Always put a line at 0 when it goes through 0. So I can go from what? -2 to 0 and from 0 to 1. I have to break it up from 0 to -2 and 0 to 1. Remember, you only have the following numbers. -2 to 2 is 95%. So -2 to 0 will be half of that, 47.5%. You also know you need to know from 0 to 1, but you can't do that. You can do from -1 to 1 is 68%. So from 0 to 1 is half of that, 34%. And now what do? We add them. So now you just add those together. So from z-score of -2 to 1 which is your 50 to 80, is 47.5% plus 34%, which is, help me, 81.5? Or is it 82.5? 70. Tell me where you lost.